let's try to solve this question here. You have two parallel slits are illuminated by light composed of two wavelengths. So this is not exactly monochromatic, it's not one single wavelength, there's two wavelengths inside here. Okay, so if you shine light of two wavelengths onto the double slit setup, what happens is you see two interference happening. Two interference patterns overlapping each other form on the screen. Okay, because let's say if you send red light and green light, the red light will form its own interference pattern, the green light will also form its own interference pattern, but they are both overlapping on the same region, so the interference pattern will form on the same screen. They are overlapping with each other. Okay, but they're independently interfering. Means that if we look at red light, the red light has its own interference pattern. You look at green light will have its own interference pattern, but the pattern is formed on the same screen over here. But the red does not affect the green green does not affect the red. They are independent of each other. Okay, so one wavelength is lambda A is equal to 645 nanometer. 645 nanometer is a standard red color wavelength. Okay, so the other wavelength lambda B is unknown, which we don't know what's the wavelength. Okay, on the viewing screen, the light with wavelength 645 nanometer produce its third order bright fringe at the same place where the light with lambda B produce its fourth dark fringe. So this sentence is a bit complicated. Let's maybe write down all the information we have regarding the first two sentences first, then only we analyze this sentence carefully. Okay, so we have two wavelengths, so I'm going to draw a red wavelength first, a red plane wave. So this red plane wave here, the wavelength will be equal to 645 times 10 to the power negative 9 meter. Okay, I'm going to call this a lambda A. Then next you have another wavelength. Let's put it in green. I'm not sure what's the color actually. So you have another wavelength also arriving at this double slit over here. So this is another wavelength here. I'm going to label it as lambda B. Okay, so both of them are shining on this double slit over here, and at the distance away you place your screen, then you see interference pattern. Okay, so let's come back to the sentence that is complicated. On the viewing screen, the light with wavelength lambda A produces its third order bright fringe at the same place where the light with wavelength B produces its fourth dark fringe. So we know that lambda A, its third order bright fringe, will be at the same place with the lambda B's fourth dark fringe. Okay, so let's maybe draw the pattern for lambda A first. Lambda A, I already sketched it to be something like this. All of them has consistent brightness for all the bright fringes, the dark fringes over here. So we need to know where is the place where the overlap will happen. The overlap is happening for the lambda A's third order bright fringe. If you look at the word order, we know that, oh sorry, this is in green, this needs to be in green, and this needs to be in red, sorry. Okay, so when we talk about third order, the order means m, so in this case m is equals to 3. So m is equals to 3. We know that for interference double slit experiment, your m will start from 0. Start from 0, plus minus 1, plus minus 2, so on and so on. Okay, so because it starts with 0, we are going to label this central bright as m is equals to 0. Further out, this is m is equals to 1, this is m is equals to 2, this is m is equals to 3. So from here, we know that the place where third order bright fringe will be somewhere around here. So this is the place where your overlapping will occur, and it should overlap with the fourth dark fringe of lambda B. Fourth dark fringe of lambda B, if you look at the dark, let's look at these green fringes over here. At these green fringes over here, so this is the first time we are seeing a dark. This is the second time we are seeing a dark. This is the third time we are seeing a dark. This is the fourth time we are seeing a dark. In terms of labeling, if you want to label the m, again, since m starts from 0, the first dark here will be m is equal to 0. The second dark here will be m is equals to 1. The third dark here will be m is equals to 2. The fourth dark here will be m is equals to 3. Okay, so they are overlapping. The pattern is quite complicated, but what we need to focus on is actually this position over here. The position where we find third order bright fringe for the red light will be the same position where we find the fourth dark fringe for the lambda B. fourth dark fringe for lambda b is actually the third order dark fringe for lambda b as well. So even though we name it as fourth dark, but because when we see there's no word order, the value before this, the value before the dark, the fourth over here, cannot immediately be m. If we see that there's no word order, what we need to do, we have to count out from the central bright. If we count out from the central bright, this is the first time we see a dark, second time we see a dark, third time we see a dark, the fourth time we see a dark. Now that we know that this is the fourth time we see a dark, this is the position where it should overlap also with the third order bright fringe for the red light. Okay, but if you count in terms of m, we know that the first dark fringe here, your m needs to start with 0. So m starts with 0. So the next one is 1, 2, 3. So you see that the fourth dark is actually the third order dark fringe. Okay, so what can we say? We can say that this particular distance from the center over here, this particular distance over here, it's also the y3 for bright. It's the y3 for bright for lambda a, but at the same time, it's also the y3 for dark for lambda b. Okay, you can say this is also 3, this is also 3, so it's y3, y3, but for the red light, it's bright a, for the lambda b, it's dark b. Okay, so they happen at the same position, so the value for y should be the same. So what equation can we say? We can say that y3 for bright a is at the same position, so the y should be the same, will be same as y3 dark b. Okay, so because of that, we can expand the equation. For equation for bright, it will be m lambda d over d, but m is 3, so this is 3 lambda d over d. Okay, for dark, there's a plus half, so this will be 3 plus half lambda d over d. Okay, there's no need to differentiate between the d for a and the d for b over here. Same for the small d for a and the small d for b. There's no need to differentiate it because we are shining it simultaneously. So it means that we are applying it on the same slit and the screen is at the same distance away for both situations. In fact, there are one single situation but two wavelengths. So the d over here is the same for both sides. The big D over here is also the same for both sides, so we can just cancel them out. But before we cancel out, let's be very clear. The situation on the left and the situation on the right, they apply different wavelengths, so we have to label it very carefully to be lambda A and lambda B. Okay, so now we can cancel out the big D and also the small d over here, we can cancel out. Then our equation right now will be left with 3 lambda A on the left. On the right, you have 3.5 lambda B. Okay, so if you substitute in lambda A, which is 645 nanometer times 10 to the power negative 9, you'll be able to get your lambda B. So lambda B, if you calculate it, lambda B will be equals to 5.53 times 10 to the power of negative 7, which if we move the decimal place 2 times, you are able to change it to 5.53 times 10 to the power negative 9. What's the purpose of doing so? Because if it's negative 9, then it's nano. So this is what I'm doing. I moved my decimal place 2 times already. So if I move my decimal place, this should be 553 times 10 to the power negative 9. So this would be 553 nanometer. Okay, so this is the wavelength that is needed to shine on this same double slit in order to have your third order dark fringe for the lambda B to be at the same place where you find the third order bright fringe for the red light. Okay, so this is the wavelength that you should be using. Okay, so this is a relatively not so easy kind of question because it involves 2 wavelengths. So when it involves 2 wavelengths, I suggest maybe you need to draw the diagram. One side is enough, the upper side is enough, the lower side, if it's if it's a hassle for you, don't need to draw. But when you sketch it, right, always make sure you label the M. Okay, because by labeling your M, you can make sure whether you do everything right or not, whether your Y should be substituting 3 or 4. In this case, it's actually they are trying to trick you over here, because fourth dark fringe over here, even though it's fourth, you should be substituting in 3. And of course, make sure if there's no order, make sure you count properly. If there's the word order, then the word order immediately means by the value in front will be your M. Okay, so if you be careful with all these kind of things, you should be able to get the answer correctly. So that's it for this question. Thank you very much.